Okay, so let's work through these three questions. What principal will amount to $7,500 if invested at 7% compounded semi-annually for 16 years? All right, now realize that the principal is always the original amount, and this $7,500 is what we're going to have after 16 years. So the principal should be a smaller amount than that 7,500, which tells you that this is really way too large. So let's go ahead and work through it. Let me see if I can get this little thing that allows me to write on the screen here. Okay, now, since we're only going to put one principal in, and we are compounding, this is our compound interest formula. And I may use slightly different variables than the book, but you should be able to match them up. So we have that our future value, which is $7,500, is equal to the principal times 1 plus our interest rate divided by, and I believe this book uses a K for the number of times compounded per year, raised to the K times N, and I think they use a capital N for the number of years. Okay, so let's fill in. Our future value is the 7,500. This is what we want it all to amount to after 16 years is over with. So we're going to put 7,500 over here. We don't know what our original investment, our original principal is, so that's an unknown that we'll be solving for. Our interest rate is 7%, so as a decimal, that's 0.07. Compounded semi-annually is twice per year. And then 16 years, so we're going to have twice per year times 16 right here in the exponent. All right, now let's work this out. First, I'll go ahead in my calculator and put 1 plus 0.07 over 2 into my calculator. That gives me 1.035. And while I'm at it also, I'll go ahead and multiply the 2 and the 16 to get the 32nd power. Now, next we want to do the 1.035 raised to the 32 power and get whatever that number is. So I'll leave the rest of it alone. Let me put that into my calculator. And I get the decimal, 3.0067 07586. And though it's tedious writing out all these decimals, for the sake of, it can really throw our answer off if we round off. So we want to take those out even though it's tedious. So let's notice we have a number multiplied by a variable equal to something else. And recall from algebra, to get rid of something being multiplied times our variable, we just divide it out. And of course we have to do that on both sides. And of course, I'm going to run over the top of this and I'll erase it here in a minute when we get ready to do the next one, so it's not in the way. So I'm going to go ahead and put that left side into my calculator, 7,500 divided by this number, and I get 2,494.42. And then, of course, over on this side, this cancels out, and we have P. And, of course, this amount is less than what we started with, which we should expect. And, of course, oh, it's not going to let me click on that while I've got this going. But there we've got our initial principal. You might want to pause the video to write this down because I am going to erase this in a moment in order for us to see all of 6. All right, so number 6 is Really a similar problem, except that this time we are given our principal. So what is the future value if $10,000 is invested for 7 years at 8% compounded annually? Okay, now, again, we're only investing one time, which leads us to this compound interest formula. This time, though, we want to know the future value, and we're given the principal. So let's fill into this thing again. So our principal is going to be 10,000. All right, and then 1 plus 0.08. This time we are compounding annually, so that's just one time per year, which makes that much nicer. And then 1 times the number of years, so 1 times 7. I'll just go ahead and put 7 there because we know 1 times 7 is 7. All right, now let's just work all this out. So this one's a little quicker. So we'll have 10,000. 1 plus 0.08 will end up being 1.08 to the 7th power. And we've got to put the 1.08 to the 7th power in our calculator first. Let's see what that is. That ends up being 1.713 824 269. And now I can multiply it times the 10,000 and get my future value, which is going to be 17138.24, and I'll round it off to cents at this point. So it looks like you were close, but somewhere you goofed up in there. All right. So let's go to number 7. I'll leave it there for just a second so you can write that down before I have to erase the screen, because when I pull it up, it's going to go on top of question 7. So you might want to pause the video. And I was wrong. It didn't cover it up, so that's good. Okay, so question 7. Find the future value of an ordinary annuity of $70 paid at the end of each quarter for 2 years if interest is earned at a rate of 3% compounded quarterly. Now let's notice this time where our $70 is being paid on a regular basis instead of one lump principal like we had in 5 and 6. So we're in a different formula now. So I'm going to write down the formula here, and hopefully I'll use the same variables that our book does, but it's essentially the same. All right. So 1 plus R over K raised to the K in, oops, let's see if I can erase that. All right, I went ahead and wrote it out so you wouldn't have to watch me write that tedious thing. Okay, so let's fill into this thing. We want to find the future value, so we don't know this, but we are going to pay $70 each quarter, so that's the D part right here. So the future value is $70. And then we'll have 1 plus, our interest rate is 3%, so 0.03. We are compounding quarterly, so that's 4 times per year, raised to the 4 times the number of years, so 4 times 2. Minus 1. All over this same thing right here, R over K, so 0.03 over 4. Now, let's work through this thing. quite tedious kind of work through, but all right. So first, I'm going to go to the innermost set of parentheses and do that. So I'm going to do the 1 plus 0.03 over 4 first. All right, so if I do that, 1 plus 0.03 over 4 is going to give me 1.0075. And then let's, while we're at it, multiply 4 times 2, it's to the 8th power. And then on the bottom, we can kind of take a shortcut because 0.03 over 4 will always be this part right here. So it's without the 1 being added, so it's 0.0075. All right, now in my calculator, I'm going to go ahead and put 1.0075 to the 8th, and I'll subtract 1 all in my calculator at once. So when I do that, I get 0.061598848. Now I can actually do the rest of this in one step. I can say 70 times the top of this fraction divided by 0.0075. So that's what I'll do. I'll put 70 times this decimal divided by 0.0075 in my calculator. And I get 574 and 92 cents. All right, and of course we can check ourselves. I know you can't check without actually submitting it, but let me leave it there for a second so you can stop the video if you need to write this down. But I'm going to quit from there, and that was number 7 as I recall. And let's notice it's 574.92, so all looking good there. So hopefully that will help you through those 3 questions.